Welcome to section 5.5. Section 5.5 is going to be working with the derivative of natural logs and logarithmic differentiation. So the first thing I always like to do is, how do we find the derivative of a function raised to a variable? What happens if I give you x to the x plus 1 and ask you to find that derivative? Notice we have a variable in the exponent. We've never seen that before, unless we were talking about our e's. But this is a variable to a variable exponent. So we don't, at this point, have a rule to be able to find that derivative. By the end of this section, we will be able to find that derivative. Before we get to that point, I want to go ahead and go through how to find the derivative of a logarithmic function. So today's rule, and I'm going to go ahead and just give that rule to you instead of proving it. It's kind of a nasty, ugly proof. So if I give you f of x equals the natural log of a function, not just the natural log of x, but it's the natural log of a function, then the derivative is the derivative of that function divided by the function. So I take the derivative of the inside part of the natural log and divide it by that function. So if I give you the natural log of x, the derivative of natural log of x, I can go ahead and put my d dx, means derivative of natural log of x, is going to be the derivative of the function, which is 1, derivative of x is 1, divided by what I took the function of, which is x. So the derivative of natural log of x is 1 over x. What if I give you the natural log of 3x? Well, here, my first derivative, I can take the derivative of the function, which derivative of 3x is 3, divided by that function, 3x. 3 divided by 3x gives us 1 over x. Now, something that we could do with a little secret. I'll give you a little secret, little hint. Notice natural log of 3x. We can say this is 3 times x, can't we? Well, in that case, I have expansion rules that I learned way back in pre-calculus and algebra 2. I can expand this to the natural log of 3 plus the natural log of x, right? I was expand multiplication through addition. Natural log of 3, that's a constant. If I take the natural log of 3 in my calculator, I can do that. It's about 1-ish, right? Natural log of 3, if you don't believe me, go ahead and put that in there. Natural log of 3 gives me, oh, look at that, 1.09. How did I know that? Remember, natural log is base e. So if I have log base e of 3, remember e is 2.7, which is pretty close to 3. And my base is the same as the number. It's equal to 1. All right, so I know it's going to be very close to 1. So anyway, this is a constant. Derivative of any constant is, constant, 0. So I'd have 0 plus the natural log of x. Natural log of x derivative is 1 over x, which is what I had over here. So we could over here say 0 plus 1 over x, which is 1 over x. So two different ways of looking at this problem. I show this because this is going to make our life a lot easier in the days to come. And it might even happen today that it makes it a little easier. All right. So in example 2, we have f of x equals 2 natural logs of x to the third. I'm going to again bring those natural log rules back. Recall I can bring this exponent to the front. I can multiply it to there. So I can rewrite this as 6 natural logs of x. My derivative of 6 natural logs of x, since 6 is a constant, I have 6 times that. So I'm going to have 6 times the derivative of natural log of x, which is 1 over x. 6 times 1 over x is, 6 over x. Now again, what happens if you don't remember that 3 can come to the front? Well, let's work it out. So I can have f prime of x equal to 2 times, I'm going to take the derivative of the function, derivative of x to the third is 3x squared, over the function, x to the third. 3x squared over x to the third, my x's will cancel, 2 of them. Nope, I just have 1 there, don't I? So that leaves me with 2 times 3, which is 6 over x. Hey, they're the same thing. So again, doesn't matter which way you look at it, we're still going to get the same answer. Natural log of 2 over 3x squared. This one, we're definitely going to break up. I see this as the natural log of 2 minus the natural log of 3x squared. Natural log of 2, I know the derivative. That's a constant again. That's going to be 0 minus natural log of 3x squared. I could break this up. Since I know the derivative of 3x squared pretty quickly, I was going to go ahead and leave it as 6x over that function, 3x squared. But that's going to reduce to negative 2 over x, isn't it? And then finally, my last example, if I give you the natural log of x to the third plus 3x minus 2, my first derivative is going to be derivative of the function, which is 3x squared plus 3, divided by the original function, x to the third plus 3x minus 2. And that gives you our derivative. So that gives you an introduction of how to find the derivative of a natural log, remembering your log rules and how to expand things out. Makes your life just a little easier, and it will continue to make your life easier in the days that come. So if you have questions, let me know. Good luck, enjoy, and happy finding those natural log derivatives.